Assalamualaikum warahmatullahi wabarakatuh and good day to all of you. So today we'll continue with lecture 10, which is distributed web-based system. So for this chapter, I will go back to our textbook, which is Distributed System Principle and Paradigms by Martin Van Steen and also Andrew Tannenbaum. Distributed web-based system, the www World Wide Web is a huge client server system with millions of servers, and each server hosting thousands of hyperlinked document. So what does hyperlinked document means? It is simply a web page that contains hyperlink or links to other web page, file or online resources. So documents are often represented in text, um, plain text, HTML. I mean, earlier days of the World Wide Web, so most of the documents are in plain text, and then we have HTML format, and later we have the XML format. So there are some alternative types for multimedia resources, which is multimedia data, which is images, audio, video, application, and also PDF and PostScript. And the documents also may contain scripts which is executed by the client side software. So in a traditional web-based system, let us talk about the architecture of the traditional web-based system. So in the traditional web-based system, many web-based systems are organized as relatively simple client and server architecture. So basically, client machine will send document request, which is the HTTP request. So the browser on the client machine creates an HTTP request, and this request is usually triggered when the user types some URL of the website or clicks any link. So the request is passed to the operating system, which sends it over the network to the web server. So in the web server, web server will fetch documents from local storage, and it interprets the requested file path, for example, index.html, and the server will retrieve the requested source file from the local file. And lastly, the server will send response back to client after HTTP response. So after finding the requested document, web server will send it back across the network. So for the web documents, the fundamental to the web is that virtually all information comes in the form of a document. So most documents can be divided into two parts, which is the main part is to provide the structure or template, and it's written in markup language like HTML or XML. And also for the second part, where the document will contain various content elements, such as text, image, styles that fill in the template. So here, for each top level type, so this is the top level type, so there might be several subtypes available. For example, the web documents with type is text, we may have subtypes plain text, HTML, and also XML, and then and so on and so forth. And the type of document is then represented as a combination of the top level and also the subtype, such as, for example, application and also PDF. Right. So many subtypes are experimental, meaning that a special format is used, requiring its own application at the user side. So, like for example, if web server would like to open, like for example, a PDF document, so we need a separate program that will run aside a browser, or we can also have a so-called plugin that can be installed as part of the browser. So basically here, the combination of HTML with any other markup language, such as the combination of HTML, the markup language, or any other markup language such as SML, with scripting will provide powerful means for expressing document. Now, the basic architecture in slide 1, we can extend it. So this is basically a slide 1, but we extend it to with numerous components to support the advanced type of document that is just described. So here, when we extend it, websites can be organized into 3 tiers depending of what are the combination of types that we have for the web documents. So basically here, in step in the first part, step 1, the web server receive a request from client. So on the client side is still the same, but now the operation on the server side is slightly changed. And then web server receive request from client, so the web server gets request from the browser. So it recognizes that the requested resources must be handled by a CGI program rather than returning the static file by the HTTP request handler. So the server will delegate here. They will delegate the request to a CGI program. So instead, previously in the traditional architecture, so the web server will fetch a document by themselves, but instead of fetching a document by itself, the server will hand over the entire job to the CGI program. So because to the server, it looks as if it is simply asking the CGI program to fetch the document. And on CGI program will start process the request to fetch the document, and it will interact with the database. So CGI will generate the HTML page, meaning this page is not read from the disk. It is generated by the CGI program on the fly, and server will return the generated document to the client. So basically, the server does not know whether the document came from the file system or was generated dynamically by the CGI program. So for the web service, at certain point, still under architecture, okay, but this is the architecture for web services, because we know that web server also can provide web services. So at certain point, people started to recognize that it was more than just a user and website interaction. Sites could offer services to other sites and when a website offers services to other sites, so standardization is needed. So the operation is in the diagram. It shows that how web services rely on 3 key standards, which is UDDI here, and also WSDL here, and also SOAP for protocol for communication. So UDDI is to directory for service lookup. The WSDL is a language to describe service, and SOAP is the communication protocol. So a server machine, in the first server machine, there is server application component. So the server application first describe its service using WDSL, because we already knew that I have already mentioned that the UDDI is WSDL is the language to describe services. So then the WSL will publish this description to UDDI directory here. Okay, so WSDL will provide service description, and will publish the description to UDDI directory. So UDDI is a directory for service lookup. So basically here, the UDI directory actually the role is a searchable registry. So a client application, so when they need the service, so they can then look up a desired service in the UDDI directory, and they will receive the WSDL file. So from this WSDL description, both client and server automatically generating matching stub. Yeah, so they will generate matching stub, ensuring that they share the same interface and data type or similar to, which is similar to the RPC or remote procedure call system. So in essence, here this is how standardization happened between the client and also the server. So and then now, uh, both the client application and also server application has the same matching stub. So when the client, anytime they want to call for service, so communication will take place through SOP, which standardize how messages are formatted and exchanged between the two sides. So because of these standards, the client can discover the service, understand how to call it, and communicate reliably without needing to know anything about the server's internal as implementation. So for next, we go to the processes in distributed web system. So under Apache Web Server, the observation, because we know that this is an old slide, so we are referring to the um, I think third edition of the book, which is 2012. So in the 2010s, 2010, 2011, 2012, so basically Apache Web Server dominated the websites in the world, yeah, globally. So at that time, more than 52% of all 185 million websites are Apache. So, but I think this number does not take into account verified web, meaning it's not including spam, right? So basically the server is internally organized more or less according to the steps needed to process an HTTP request. So but today, as of December 2025, so the Apache server still remain as one of, so the Apache server is no more dominating the web servers, for the web service for websites. So it's still one of most widely used web servers in the world. But now we get the Apache server has heavy competition from Nginx and Cloudflare. So it is estimated that December 2025, the percentage, it has been reduced to 24.5%, which is around 4.6 million sites. But this one does not, the calculation of the number of sites differs according to the statistical agencies. Yeah. So in 2010, during this time, the dominance of the Apache server is more on the content management. So basically, significant portion of Apache usage come from WordPress sites. So because last time Apache's using WordPress is often bundled with Apache in LAMP stack. I think you know LAMP, right? LAMP, Linux, Apache, MySQL, and also PHP. So last time in 2010, 2011, 2010 to 2015, so these two, the WordPress and also LAMP, Apache LAMP, so is linked together. But now the decline is not because people are stopping using WordPress, but because how the way website is host has changed. So two main reasons for the decline is we now have cloud SaaS platform, software as a service. So in the past, if you wanted a website, you bought a shared hosting plan that usually comes with Apache pre-installed. So today, people will use software as a service platform, SaaS. For example, the platform is Shopify, Wix, and also Squarespace. So this platform will handle the server for you. So most of them use high performance stack based on Nginx or proprietary system, not Apache. And now Apache does not collaborate with the WordPress anymore. So WordPress now collaborate with Nginx. Yeah, so basically the modern WordPress has evolved. So but regardless, because Apache Web Server still relevant until now, So we want to introduce you with the Apache Web Server architecture and Apache organization. So Apache organization is built around two key concepts, which is the hook and also the modules. So what is hook? Hook is a placeholder for a specific phase in request processing, meaning hook is as URL translation, access checking, MIME type determination, MIME multimedia data content determination. So each hook may contain several functions. Yeah, so that's why you see that there's for the hook here, there's a relation with multiple module, right? So these functions are not in the Apache core, no. So basically, the functions is provided by module. So what is module? Module is actually a shared library, and which is loaded by Apache, and this module able extend Apache's behavior. So when a request arrive from here, so the Apache core moves through predetermined sequence of hook. So move the request into predetermined sequence of hook. So it needs to be in sequence. So for each hook, Apache calls all the function registered for that hook by different module. So this create a flexible pipeline. So you can see here this kind of like pipeline where modules contribute small pieces of logic and Apache assembles them into a complete request handling flow. So because multiple modules here can attach functions to the same hook, because I have explained here earlier, hook is kind of like a placeholder for request processing and may contain several functions which resides on the module. So Apache can support many, because of this, Apache can support many features independently. So developers will typically add new functionality by writing modules and linking their function to the appropriate hook. This makes Apache a very extensible web server. So without needing to modify their Apache core. So an important problem related to client server nature of the web server can become overloaded. So to improve performance and availability, World Wide Web server are often clustered in a way that is transparent to client. So a practical solution here employed in many web server design or server cluster design and is the use of front end. Okay, so basically when you have multiple web server, so we can have a front end to redirect client requests here to one of the web server replicas. So in this figure shows the use of server clusters in the combination with a front end to implement a web service. So in the distributed web-based system, the front end actually acts as a police traffic that direct incoming user requests to different backend server to prevent any single machine from become bottleneck. So this is the basic concept of front end. But now the front end may easily get overloaded. So there are special measures need to be taken. Because why overloaded? Because all of your requests will be through the front end, and the front end need to process the request to assign the request to which replicas, which web server. So the front end may easily get overloaded. So the special measures need to be taken. There are two methods, which is the first one is transport layer switching, and second content aware switching. So these two approach to understand why we need transport layer switching or content aware distribution, because this is the approach to see how much of the request the front end looks at before making decision. So for the transport layer switching, so the front end simply passes TCP request to one of the servers taking some performance metric into account. But we have to understand transport, like the process works in layer 4 on the in the OSI layer model. So basically, the approach is blind to the actual content of the user request, meaning the front end, because it's layer 4. So layer 4, we have the datagram, right? Or packet, or layer 3 packet, layer 4 datagram. But again, when you are at layer 4, you cannot see the content, the content of the packet. So you can only read the header. So the header contains what? Contains the IP address and the port number. So if you're at layer 4, you cannot decapsulate the packet to see the content of the user request. So because of this, that's why the technique transport layer switching is called as blind technique, because it simply passes the connection to a server based on the server performance or server health, such as at that particular point of time, which web server has the least connection, or the least connection, or which one can responded the fastest recently. So under content aware distribution, the front end reads the content of the HTTP request and then select the base server. Why? Because for the content aware distribution, um, they do not sit on the TCP layer, right? So because they do not sit on the TCP layer, they sit in the application layer of the OSI model, layer 7. So here, when you are at layer 7, so you are able to read the content of the packet. So how it works, the front end reads the FTP request, like for example the URL, the cookies, the file type. So because of this, they can make a best decision. So hence the reason it is say content aware, because the decision of the assigning the web server is depends on the requirement, the request of the client. So but you have to take note that when you are at the when you want to open the content of a packet to read the message, okay, so you must fully terminate the TCP connection. Then you can inspect the data inside before deciding where to send it, which server to send it. So for example, if there is a video request to a server with high speed disk and an image request to a server optimized for it. So why content aware distribution be so much better? Of course lah, yeah, it's because it has several advantages. So higher response time as server user catching for the same request. So if the front end always forward request for the same document to the same server, so that server may be able to effectively cache the document, resulting in higher response times. So next advantage is they can distribute the collection of documents among the servers efficiently. Sorry, this one is efficiently. Yeah. So because it is possible to actually distribute the collection of documents among the servers, instead having to replicate each document for each server. Okay, so they are not doing replication but of documents, they are doing distribution of document. And then storage management as a dedicated servers to handle special documents. So a problem with content aware distribution is that the front end need to do a lot of work. Yeah. So and then there is a disadvantage that the switch cannot see the content, right? But it's fast. For this technique, it's fast because they just blindly pass the TCP request to one of the servers. But it's not intelligent. So we need something that combine both, which is fast and intelligent. So a problem. So basically, when we combine the transport layer switch and content-aware distribution, so when we combine it, so the front end will has two tasks. So first, when a request initially comes in, the front end must decide which server will handle the rest of the communication with the client, and the front end should forward the client's TCP message associated with the handed off TCP connection. So when we combine these two approach, the goal is to make the front end switch smart enough to choose the right server, but lightweight enough not to overload the front end. So the work is shared between the switch, which is the front end, and the dispatcher. Dispatcher is the content-aware decision maker. Okay, so we have two separate, but we combine both function. So so let us look at the diagram. This is a diagram of scalable content-aware clusters of servers that combine both layer 4 functionalities and the layer 4 switch functionalities, and also content-aware dispatcher. So in here for step 1, so the switch will receive a request from the client. So the switch, as we know, because it's layer 4, cannot look inside the content. It's a layer 4 switch, so cannot pass the setup request to cannot look inside the content, because it's still the content of the packet still encapsulated and not yet transmitted. So what they can see is only the TCP handshake. So what they pass here is they forward the handshake to the distributor, which is the web server, and the web server will send it to the dispatcher with the content aware logic. So basically here after the dispatcher receive the handshake, the TCP handshake, so dispatcher choose the base server based on the content such as URL, MIME type. But here, because we already knew that this one is layer 7, this one is layer 4. So distributor or dispatcher will temporarily act like the server, and they will terminate the initial TCP connection to allow the component to read the content of the client request. That is how they read the content of the packet. So when the dispatcher already decide the right server for the request, so TCP handoff will happen. So the dispatcher will hand off the TCP connection to the selected server. So this is actually a back end trick. Yeah. So because in the perspective of the switch, the session still happened. Yeah. Still on. So now, after inspection, the connection state is transferred to the chosen web server, and the switch now forward all future packets to that server here. So this one is only for the established connection to decide which web server that will handle the request, and for the future communication, the switch will forward other message to the web server, and server will directly respond it to the client. So for the catching type now let us talk about the catching type in the distributed web-based system. So catching is one of the form to ensure high performance and availability of distributed web-based system. So there are two ways to ensure availability for the distributed web-based system. First, catching. Second, replication. So there are two ways. So for the first way, catching. So catching, there are the two types, which is hierarchical catching and also cooperative catching. So before I explain about the hierarchical catching and cooperative catching, I want to briefly explain about what are the uh, other type of caching that we use in the traditional web-based system. So in the traditional web-based system, so there are two ways for client-side caching. Pertama sekali, first we use browser cache. Okay, so in the browser, so there is a cache, so we use that, and then we use web proxy. So web proxy will accept requests from local client and pass this to the web server. So when a response come in, result will be passed to the client. So this advantage, this approach ada advantage dia, which is proxy can cache the result and return that result to another client. So basically, a web proxy can implement a shared cache. But that is in the traditional where you only have one, where you have client and server architecture, which is single server. But in the distributed web-based system, so we have two ways to provide caching, which is the first one is hierarchical caching. Caches are organized in layers, meaning we have browser, proxy, and regional and then national cache. So this will help reduce overall network traffic by storing copies at multiple levels here. So disadvantage can cause higher latency because a request may need to check several caches in sequence. But if the content is a popular content, so basically we can use hierarchical caching because um, popular items are more likely found in a nearby cache. And then we have the cooperative or distributed caching. So here we will have multiple peer caches or proxies work together and share cache content. So if there is a cache miss, so cache miss means that um, when you look up for the content, is not in the cache. So that is what it means by cache miss. So a proxy checks neighboring proxies before contacting the original web server. So typically used within the same organization and LAN where proxies are close to each other. So it works best for smaller group of users. Otherwise, single large proxy may be more efficient. So now let us look at the details or extent of the cooperative caching. So in the cooperative caching, what happen is you first check your neighbors on the cache miss. So basically, as I said, this is usually used for the enterprise network. So meaning here, so when you get any HTTP request from client, so basically in the copy caching, so you need to check your own cache, your local cache first. Okay, so if there's a cache miss, so then you query the neighboring proxy cache. Okay, so if none of the neighbors have it, so the request will be forwarded to the web server. So this will reduce server load by sharing cache content among nearby proxies, because so that the every time there is a request, you don't need to forward the request to the web server. So this will reduce the load of the web server. So a cache miss happens when the requested data is not found in the cache. So basically, this is the concept of distributed cache. So the sites that installed, now we have another things that we call as web proxy caching. So the basic idea is websites install a separate proxy server that handles outgoing requests. So proxies subsequently cache incoming documents, cache and we will use cache consistency protocol that always verify validity by contacting server. So the if you look at the previous diagram, okay, sorry, this one, if you look at the previous diagram, so in the proxy caching, proxy server will sit between client and the internet. Okay, it's not diagram, sorry. In the explanation here, a proxy caching will sit, a proxy server will sit between client and internet, and it will handle all outgoing requests. So every time a document arrives, proxy stores them in its cache, so future requests can be served faster. So to keep cache document consistent, so basically we use two ways or two approach. Pertama, validity checking. Validity checking tadi ni untuk apa? So validity checking is when the proxy contacts the server to confirm the freshness of the information, the freshness of the document, yeah, whether the document is the latest document or not. And then we have the age-based consistency. So age-based consistency means that we use expiration time. So when expiration time is estimated using documents age, so each document will have an age and last modified time to decide when the cache copy becomes invalid. So the formula here estimate when a cache document expires by combining how old it is with how long since it is modified. So the age is T-cached. Okay, how age meaning T-cached means how long the document has sit in the cache. So and this one, okay, is the last modified to ensure the freshness of the documents. So, and here, alpha here is the tuning factor, which controls how quickly a cache document should expire based on its age. So basically, if you have large alpha, it means that document expires quickly. When you have small alpha, meaning the document stays valid longer. So until T expire, so the document is considered valid and the proxy will not contact the server. So after expiration time, the proxy requires the server to send the fresh copy. So I'll stop here and I will continue the replication in the next video.